started talking about our arithmetic sequences, and then we looked at a couple of arithmetic series. So remember, we have a couple of different ways that we can list our sequences, right? So we have this notation of a sub n equals 3n minus 2. Then we also looked at a couple where we like just list it as like a list of numbers. And then the last way that we can look at series is in sigma or summation notation. So sigma is a Greek letter, so it kind of looks like a big E. It stands for summing or adding together all of the numbers. Which, remember, when we have a series, that's what we're doing. We're adding each of them together instead of just like putting commas in between them. So the bottom number, which is like what k is what we plug in first. The top number is the last number that we plug into. And the equation on the right is what we plug in to. So like on the example, I'm going from k equals 1 to 12, and our formula is 4k plus 2. So I plug in 1 first, then 2, then 3, and then we go all the way up until we're plugging in 12. And we're adding all of those numbers together. It says find. We have the sum from k equals 4 to 18 of 6k minus 1. So we have two different ways that we can approach this problem. The first is, okay, again, remember our sigma or summation notation just means that I'm going to take this first one, so 4, and plug that in. Then I'm going to add, plugging in the next number, so 5. And continuing on all the way until I get to the last number, which in this case is 18. And I need to add all of those together. But that would be a lot of typing and adding in our calculators. Yes? Or we can say, okay, what type of equation is this right here? What is 6k minus 4? Linear equation. And remember, we said that when we have linear equations for our like rule, okay, we're gonna end up with an arithmetic sequence. Okay? Which means that instead of having to like add all of these together manually, we can use the sum formula that we got yesterday instead. Yes, no, maybe. Okay. Then from there, we basically have to pick apart which things go where. So the first thing that we have to decide is how many terms are we adding all up together? What we think? So we would be doing 18 if we had started at 1, right?
14.
Close. So it's gonna, if I plug in 4 first, right? 14 is how many more terms after 4 I would have, right? But then I also plugged in 4. And so just by subtracting them, that doesn't account for me plugging in the first one. So there's 15. So in general, if you need to solve for n, it's going to be the top minus the bottom plus 1. Because you have to like basically account for that I have to plug in the bottom one as well. So our sum for our n is 15. Okay. Then we want to be careful because a lot of people for your a sub 1 just plug in 4, and for our a sub n just plug in 18. Okay. Now, my 4 is the first thing I want to plug in, but my a sub 1 is whatever this whole number is. Does that make sense? Because this would be my first term. So 6 times 4 minus 1 gives us 23. And then my last term, I'm going to again plug in 18 last, but my term is what I get when I actually like plug it in. So what do we get if we do 6 times 18 minus 1?
107.
Sounds good. And then we can plug all of that in to find our total. And what do we get? Did we get 975? Someone? I feel like that's what we're supposed to get. Okay. This is a multiple choice question, so we would get C. Yippee! So sigma notation is not super hard, even though it looks kind of funny. The hardest part about it is just remembering like which one each thing represents. Basically. What questions we have there? Alrighty.